Hi, this is Gerald Calloway, and in this video, we're gonna cover water generation, uh, agriculture in extreme environments, and hopefully be able to get to SMSR power plants, their design and how they function. First of all, water creation. Water is the most valuable substance on the planet. It makes gold, diamonds, all that looks silly because you can't drink them to stay alive. The human body needs minimum 3 quarts a day. That's minimum. In your hot environments, it skyrockets. The matter of fact is, this video is going to give you an insight and the ideology of how to build massive water generating plants. Okay, when I introduced this, I mentioned Death Valley and the Sahara Desert. I'm going to focus on Death Valley right now because it's a smaller scale problem area. And there's plenty of desert out in Arizona, there's plenty in Utah, there's plenty of deserts everywhere. And quite frankly, the southern Midwest belt, Oklahoma, Kansas, and all that, are starting to turn back to the Dust Bowl. So water is the most crucial thing. And the upper Midwest is hurting bad because the great aquifers being tapped, which I plan to refill to distribute the water for everybody to be able to have massive agricultural programs. Okay, I see here the VAPP plant is the first one up. What this plant does is we're building a dome, the framework of a dome with plastic, and we're taking glass sheets and we're putting a substance on the inside of it. So it's on the inside, so as the sun comes in, it passes through the film, but when it hits the water or up on another side, it gets bounced back. It's something similar to what solar panels do, but there is the film out there. I think it's around 90% efficient. We want to get that to 100. And if you think about it, you have a round dome, and we're talking the scale of minimum half mile. I want a mile, 2 mile ones, but we'll build up to that. Even on a half-mile one, if we have a dome that's built of plastic, and then you have the glass panels in there, and on the inside you have the film that refracts the light back into the water, and it reflects up, it's going to be a big old bouncing thing. The theory here is that when you trap the light and keep trapping the light, it'll start to glow like a star. I mean, even in daytime, you'll see this thing just lit up full of light, which light is energy and causes heat. Now, at the top of these domes, you have the collector, which goes to a great big spiraling cooling tube that runs off until it's cooled and turns the water, and then you drip out H2O. I can't really explain it any easier than that. The dome itself will actually, from its weight, will ride like 3-4 feet into the water. They're going to be on poles, plastic poles that last forever. Huge ones, 8-inch. It's pretty powerful. It'll be able to handle it. But the dome floats. So as the tide comes in and goes out, it can adjust, but its weight is what submerges it 2 to 3 feet, maybe 5 feet. Doesn't really matter. Depends on how big the dome is. You can go 20 feet. What the matter is that you're free floating. And out in the ocean, there's plenty of sand and there's plenty of rocks. You can just make saltwater cement, and you form them in these little pylons. They look like the old jacks when you play jumping jacks as a kid, and it looks like jacks, and you just pour them out in front of the whole area till you get like a 20-foot high all the way to the sea bottom breaker. Doesn't matter, take rocks, whatever you want to throw out there, but it's protected by a breaker, so you're not really worried about waves smashing into it. it's protected by the breaker. Like in harbors, you see that area that goes out, so it breaks the waves so the boats don't smash into the docks. That's what we're talking about here. That's the e-vapor. Very simple. I mean, anybody who watch a moonshiner program and seen a still knows exactly how it works. But instead of fuel, I'm using the light coming in, trapping it, making it rebounce in there, and there's no telling to how hot that's going to get. You know, it has to be done by experiment, but it'll do the job of boiling the salt water to make water evaporate. All right. The other point of water creation is electrolysis machines. Everybody's been in science where you take a battery, you stick the positive and negative electrodes into the water, and then you put a little test tube over full of water, and you see the water be pushed out. One's oxygen, one's hydrogen. Now there's two things you can do with this. You can ionize and form O2, which grabs, or H2 that grabs the O, or you can use that as a fuel, oxygen and hydrogen mixture, to burn furnaces and boilers to be able to spin turbines and make electricity. This is especially good on Titan. You know, plenty of ice. Use oxygen and hydrogen in your fuel. You know, you have methane. You know, that takes a whole nother thing to collect it, but in immediate land, you can immediately have electrolysis machines making oxygen and hydrogen to be able to burn it, to spin your generator so you have power for heat, oxygen scrubbing, yada, yada, yada. And another thing is you have pure oxygen. So you can tap some of that off instead of using it as fuel, because hydrogen burns way better, it just needs oxygen to burn. But you have now oxygen, a life-sustaining gas that you need to breathe. Very important. But I'm getting off the beaten subject. That's another video. Now, these two water systems, we're talking India is dying for water. Saudi Arabia dying for water. Death Valley. I said Ethiopia, I hope, because that's pretty bad for them, and the Middle East countries. I just want to make sure I cover the base. I got a lot to cover here in 15 minutes or less, and it's not easy. But those countries should immediately be sent this video, and if they need any help with the theoretical part of it, I'm sure I can be more than happy to help you out. There's also another power plant that I call the Venusian thermodynamic power plant. Now what Venus has is an extreme atmosphere. This is where I got the idea. The atmosphere is like 800 degrees and a bunch of gases that are in there, methane. But the thing is, hydrochloric acid is in the air being suspended. I originally wanted to duplicate that inside a plant to boil water to be able to spin turbines, but due to the danger of it, we should leave that part alone, because methane is 3 to 6 times a greater heating greenhouse gas than carbon monoxide and carbon dioxide. So we want to pump these plants with methane, and we use the same technology as the domes for the water, where we're refracting light in there, and yet it has a greenhouse gas that's going to shoot that up to 4, 5, 6, 800 degrees. You know, that again is build one and let's see what happens, because then you have no fuel needed, and you have water circulating inside of it, which is being boiled by the light energy being contained, and with methane gas being inside of it as well to amplify that effect. That's going to be a very easy and quick fix. We could do that across the whole world and stomp out this greenhouse gas emissions. I mean, it has no output. It uses light and methane gas in combination to create energy, which is transferred to the water, which boils, which turns a turbine, which feeds a generator. Very simple. Very, very simple. All right. Now, the agricultural part of this, like, I'm talking Death Valley, and everyone's going, well, no, that's a site. I don't want it destroyed. Yeah, you want to starve? You want to be thirsty the rest of your life? That's California. They're dying for water. I mean, it's almost as bad as Ethiopia. Crops, everything, everybody wants water. Population's growing. You need way more water. And if you want to save Death Valley, then you know what you're doing. You're creating your own death because you're stopping agriculture and water plants from being built. This is really ridiculous. Now, I know Arizona, Nevada has a vast amount of deserts. I don't really care where it is. I projected approximately 100 miles by 30 miles, for the desert one, or Death Valley. See, Death Valley has mountains. So you can terraform. You take the water, put it up on top of the mountain, and let it trickle down. So we're going to terraform that whole side of the mountain and make crops. What we're also going to do is put up the plastic domes with the glass. I think we can get away with plastic because what we're trying to do is negate, say, 30% of the sun and put it more to a realistic UV level to grow crops like corn, lettuce, potatoes, all that stuff. I don't really know why they would not want this, but wouldn't it be better to go visit a terraformed mountain range and agricultural center? Because these places, they have to have a plastic factory, they have to have a glass factory, they have to have agricultural colleges on site actually learning and developing this technology, and there has to be a rail system because we're going to bring things on rail. I don't know if there's any dead rails out there we could re-enter or revamp and make to where we can have it in. But with the SMSR power plant, we're going to be able to do it with our own energy created. So I think I'll save that for another episode because it's like a locomotive, how it gets its power, but it uses diesel. But what I'm doing is I'm taking a salient rotor generator with an ABM, and I'm reducing the spin cycle. Right now, alright, I'm not going to get into that right now. We're going to focus on Death Valley or a good stretch of desert. I really think a good stretch of desert is going to be 100 miles by 20 miles to establish the first one. We'll build it in like 10-mile increments, but there has to be plastics, there has to be a plastic plant, there has to be a glass plant, there has to be agricultural colleges put there, even if it's in a Quonset hunt or a blow-up Quonset hunt to start with. But we need actual people there to introduce this system to this the area we're working with. And Death Valley makes a really good sense because I can terraform the entire mountain range, and at the bottom I would have a large pool of tilapia, perch, whatnot. It's going to be 100-mile stretch of fish and a big old pond that has to be built, which can be just plastic sprayed to hold the water and then a rubber mat put over it so it's solid. That's not a problem. But the idea is you start at the top and you dump water in, and each level's on a quarter bubble. Without going into great detail, I was supposed to have a level here, but I spaced it. But anyway, if you take a level and you turn it just a little bit to where 1/4 of the bubble's tilted, that's the tilt you put on each level. So you can water that, spray it, The water will go down, go into the hydroponics, and go down and trickle off into the next layer. And then so forth, and then so forth. Then when it gets to the fish will actually add nitrates to the water, so we can pump that right back up with power plants, which is going to be called the Venusian atmospheric power plants, the one where we have methane in it, and the sheeting to where 90%, 100% goes in, 90% gets refracted around, and it never escapes. Creates like a star effect. And then we can pump the water right back up and just keep using it. And we'll add new pumps as we put new 10-mile sections in, or 1 mile. I don't know how they want me to do this. But see, just because I have an idea and I know what I want to do, doesn't mean that they're going to want to go that way. It's like life, you know. You can try to help somebody, but they don't want help. It's a waste of time, man. You gotta cut bait. I also want to introduce the fact. Oh, 16 minutes. Damn it.